Hello everyone and welcome back. So in our last lecture we did some problems based on gradient of a scalar function. Now here in this part also we will do some examples related to gradient of a scalar function. Now today's topic is directional derivative. So first let's see the definition. What is the directional derivative of a scalar point function? Okay, so the derivative of a point function, it may be scalar or a vector, in a particular direction, okay, in a particular direction is called its what? Directional derivative. So this is important. You see, the derivative of a point function, it may be a scalar point function or may be a vector point function in a particular direction. So we need one direction, and that is called what? Directional derivative along that particular direction. Now let's see what is the formula. The directional derivative of a scalar function phi in a given direction a bar. See, the function is phi and the direction is what? A bar. Okay, so it's nothing but the rate of change of phi in that particular direction. So how will find it? It is given by the component of grad phi in the direction of what? A bar. So the formula for directional derivative is gradient of phi dot a bar. So in that particular direction, which direction? A bar. So dot a bar divided by the magnitude of the direction. Okay, and the maximum directional derivative will obtain by this formula. What? Modulus of grad phi. Okay, so there are two formulas. One is how to find the directional derivative of a function, and then how to obtain the maximum directional derivative. Now let's see the problems. Problems are very simple. Now see, this is our first problem. Find the directional derivative of a function phi, where phi is 4xz square plus x square yz, and the point is 1. At that particular point we have to find 1 minus 2 1, and the direction is also given here. This is the direction. So we need two things. One is the function and another one is the direction. So here phi, the function is 4xz square and then x square yz, and the direction, let it be a bar, which is 2i cap minus j cap minus 2k cap. So first what we need to find? Gradient of phi, means nabla phi. So you know that it's I del phi by del x plus j del phi by del z, del y, and then k del phi by what? Del z. So we have to differentiate now. This is our phi. So first we will differentiate phi with respect to x. So what you will get? So here 1x is there. So it will be 4z square plus, if we differentiate this with respect to x, it will be twice x yz. Twice x yz plus j cap into, now we'll differentiate phi with respect to y. So in the first term there is no y, so it will become 0. In the second term y is there, differentiation of y is 1. So we have x square z, and then k cap into, now we'll differentiate with respect to z. So here we have one z square. So derivative of z square is 2z. So it will become 8xz, and here there is 1z. So after differentiating we will get 1. So this will become x square y. Okay. So this is our what? Gradient of phi. Now what to do? Since there is one point given, so at that particular point we have to find the value of the gradient. So what we have to do? In place of x we will put 1, in place of y we will put minus 2, and in place of z what we will put? We will put 1. So after putting these values, the first term will become, so it will be 1, then minus 2 and 1, and here we will put 1. So it will become 8i cap 4, and then there is a minus sign. No, the point is, okay, so it will be minus, okay, minus 1. So this will become how much? If we put minus 1 here, so it will become 4, and this minus minus 2, 4 plus 4, 8. Next one is, if we put here x is 1 and z is how much? Minus 1. So it will become minus j cap. And then finally the third one become minus 8 and then minus 2. So it will become minus 10 k cap. So this is our grade phi at a particular point 1 comma minus 2 comma minus 1. Now the direction is also given, a bar is also given. So let us find the magnitude of the direction. So it will be root over is 2 minus 1 minus 2. So 2 square plus minus 1 square and then minus 2 whole square. So this is how much? 9. So therefore the required directional derivative is, what is the formula? Gradient of phi dot a bar divided by magnitude of a bar. So grade phi we have, which is 8 I cap minus j cap minus 10 k cap dot a bar is 2 I cap minus j cap minus 2 k cap whole thing divided by how much it is? 3. Okay. So you have to calculate it. So what will be the value? After finding dot product is 16 minus minus plus 1 and then minus minus again by 3. So the answer is 37 by 3. Okay, so it's very simple. So this is what the directional derivative of the given function phi in a given direction a bar. Now let us go to the second problem. Find the directional derivative of phi of x comma y comma z. Here the function is given, phi function is given, okay, and two different points are given. So phi is x y square plus y z cube, and the direction, see in which direction we have to find? PQ. So that PQ bar we have to find. So this is nothing but a bar. So how to find PQ bar? Position vector of q minus position vector of p, means second minus first. So position vector of q is how much? It will be 3 I cap plus j cap plus 3 k cap minus, and position vector of p is how much? 2 I cap minus j cap plus k cap. Okay. So 3, 1, 3 and then 2 minus 1 plus 1. So after calculating, it will be I cap plus 2 j cap and then how much it is? 3 minus 1 plus 2 k cap. So this is a bar. Now we have to find gradient of phi. So grade phi is what? I cap del phi by del x plus j cap del phi by del y and then k cap del phi by del z. Okay, so this is equals to I cap. Now we'll differentiate phi with respect to x. So what we'll get? Y square. Okay. Then j cap into, if we differentiate phi with respect to y, it will be 2xy plus z cube. And then k cap into how much it is? Del phi by del z. So in the first term there is no z. So it will become 3y z square. Okay, 3y z square. Okay, now at which point we have to find? At the point P. Okay, at the point P. So gradient of phi at the point 2 comma minus 1 comma 1. So what to do? We have to put 2 in place of x, minus 1 in place of 1 y and 1 in place of z. So after putting all these values, what we will get? So it will be I cap minus this will be minus and then again plus. Okay, 1. So if we put 1 minute. Okay, so x is how much? X is about 2. So 2 into 2, it will become 4. So then minus 1. So it will be minus 3 j cap. And the last term y is minus 1 and z is 1. So it will be minus 3 k cap. So this is our gradient phi at the point 2, minus 1, 1. Now directional derivative, but before that you can find magnitude of a bar. So a bar is which one? A bar is this one, pq bar. So it's root over 1 square plus 2 square plus 2 square. So again it is how much? 3. Now the directional derivative. So the directional derivative is what? Nebula phi dot a bar divided by magnitude of a bar. So nebula phi is I cap minus 3 j cap minus 3 k cap dot a bar is I cap plus 2 j cap plus 2 k cap, whole thing divided by 3. So after calculation you will get minus 11 by 3. Okay, this will be the answer. So all the problems are very simple. Okay, so after if you understand the first problem, then by seeing the next question you can try yourself first. Then if you won't understand, then you check the video. Okay, now in what direction from 1 comma minus 1 comma 1 comma 2 is the directional derivative of phi is maximum? So this is a little bit different. So you remember, no, maximum directional derivative is what? Magnitude of the gradient, nebula phi. So let us find it. So phi is how much here? Phi is x y square z cube. Then let us find gradient of phi. So gradient of phi is again I del phi by del x plus j del phi by del z, del y, and then k del phi by del z. So this will be I cap del phi by del x will be our y square z cube. And then this will be our 2x y z cube. Then k cube into, if we differentiate with respect to z, it will be 3x y square and then what? Z square. Now gradient of phi at the point, one point is given, minus 1, 1 and then 2. So what to do? In place of x you put minus 1, in place of y 1, and in place of z what? We'll put 2. So after putting all this value, we'll get 8 I cap minus 16 j cap minus 12 k cap. So this is our gradient phi at a particular point. Now how to find the maximum what? Directional derivative. So therefore first what to find? First we have to find the directional derivative is maximum. Okay. So the maximum directional derivative occurs in this particular direction, in the direction of what? Nebula phi. Okay, nebula phi, which is how much? 8 I cap minus 16 j cap minus 12 k cap. Now we have to find the value, maximum value. So the magnitude of this maximum directional derivative is what? Modulus of grade phi. So which is root over 8 square minus 16 square and then minus 12 whole square. So after calculation you will get this one, 464. So let us move to the next problem. So again, in this particular problem, what to find? Find the directional derivative of a scalar function phi in the direction of the outer normal to the surface. So here the problem is a little bit different. Okay, one surface is given and the point is given, at which point you have to find the directional derivative. So first what we'll do here, phi is what? X, y and then z. So like earlier problem, we'll find nebula phi, which is how much? I cap del phi by del x. So del phi by del x, if we differentiate this with respect to x, we'll get yz, j cap del phi by del y, it will be xz, and then del phi by del z, it is how much? xy. At which point we have to find? The point is given 3, 1 and what? Minus 3. So therefore gradient of phi at the point 3, 1, 3. So how much we will get? 3 1, so it is 3 I cap plus 9 j cap, again 3 k cap, right? Now one surface is given. Now this part you just observe it very carefully. The given surface is z equals to how much? xy. So we can write z minus xy equals to 0. Okay. So let this surface denoted by like this. Let the surface is suppose S is z minus what? xy. Okay. So now let us find gradient of this surface. So it will be I cap del S by del X, j cap del S by del Y, and then k cap del S by del Z. So in this particular direction of the surface, we have to find the gradient. So I cap del S by del X. So del S by del X is how much? We will differentiate this with respect to X. So how much you will get? You will get minus Y. J cap with respect to Y, you will get minus X. And then finally, if we differentiate with respect to Z, it will be what? 1. Okay, it will be 1. Okay, so this is suppose A bar. So A bar is gradient of S at which point? 3, 1 and then 3. So let us put all this value here. So if we put 1 here, it will be minus I cap. And then if we put 3 here, minus 3 j cap plus what? K cap. Right? So what will be the magnitude of A bar? This will be our 1 plus 9 plus 1. It will be root over 11. So now we can find the directional derivative. So the directional derivative, okay, the directional derivative in the direction of the normal to the surface is how much? Nabla phi dot, in the direction of the surface it is A bar divided by magnitude of A bar. So everything we find, what is nabla phi, gradient of phi 393. So it is 3 I cap plus 9 j cap plus 3 k cap, okay, dot, and then A bar, which is minus I cap minus 3 j cap plus k cap divided by root over of 11. Now if you find the dot product, after finding the dot product, is minus 3 minus 27 plus 3. Okay, so it's minus 27 by root over 11. Okay, so let us do one more problem. Find the directional derivative of phi. Point is given in the direction of this. So it's a very simple problem. So I hope that in this problem you will do yourself. First, what to do? We have to find nabla phi. I'm writing the values so that you can match your answer with this one. So first you have to find nabla phi. So it's how much it will be. After differentiating, you will get I cap into del x. No, so it will be y plus z. Okay, so y plus z. Then j cap into, you will get x plus z, and then k cap into y plus x. After that, you find nabla phi at the point 1, 2 and then 0. Okay, so you will get 2 I cap plus j cap plus 3 k cap, right? So then A bar is also given. It is I cap 2 j cap plus 2 k cap. And then magnitude of A bar will be 3 again. So directional derivative is how much? Nabla phi dot A bar divided by modulus A bar. Okay, you put all the values. After putting all the values, you will get what? 10 by 3. Okay, so what is the maximum value? Maximum value is what? Modulus of gradient phi. So gradient phi is how much? This is our gradient phi. So it will be root over 2 square plus 1 square plus 3 square. How much it is? Root over 40. Okay. So you just practice some more problems from any book. The problems are very, very easy. So in the next part, we'll do some more problems on gradient of a scalar function of different type, like in the direction of unit vector to the surface. Okay. So till then, thank you very much for watching the video.